Lesson 54, Box and Whisker Plots. Let me start by saying that this lesson is a really fun lesson in my opinion. I hope you think so too, but as long as you know how to order numbers numerically, find the medians, you can do this lesson. Okay, it's all about making sure they're in order and then you find 3 different medians. That's it. So a box and whisker plot displays data that are divided into 4 groups, and it's very important that you know the names of each of these points. Okay, so the first point that we have is the minimum, and we will plot that as our lowest number. Okay, the lowest number is our minimum. Okay, that's what goes first. Our Q sub 1, our Q1, or our first quartile is a median of the lower. Okay, so I'm going to write the median, or the second quartile, okay, also known as Q2, is the median of all. Okay, so the median of the entire set of data. The third quartile, or the median of the upper, is our third quartile, or Q3, and our maximum is our largest data value. So those are the 5 points that you need to know to be able to make a box and whisker plot. And it says that it's divided into 4 groups. Those groups are the first quartile, that's this whole first quarter piece, the second quartile, the third quartile, and the fourth quartile. Okay, some other information. The interquartile range, or the IQR, is the difference between the third quartile, or Q3, and the first quartile. So that means that IQR equals Q3 minus Q1. That's it. Okay, that's what you need to know about IQR. The outliers are any values x such that, okay, we have x is less than Q1 minus 1.5 times the IQR, or that x is greater than Q3 plus 1.5 times the IQR. So what we're saying here is if it's on the lower end, it will be less than the first quartile, and then it's going to be minus. Okay, so the lower end is less than, minus, and first quartile. The 1.5 QR stays the same in both. If it's on the upper end, if it's a big number that doesn't look like it belongs, we can test it by seeing if it is greater than the third quartile, which is on the upper end, plus the 1.5 IQR. So if it's on the upper end, it's greater than and plus. Lower end, it's less than and minus. So you need to make sure that's in your notes too. Alright, it says, box and whisker plots show scores on a science test. Use interquartile range to identify outliers. So, on this one, they've given us the box and whisker plot, and I'm going to start by labeling what each of these looks like to us. Okay, so on these dashes here, these are going by tens. So this one looks like it's right between 10 and 20, so we're going to call this one 15. This one looks like it's right at 60. This one looks like it's right at 70. This one looks like it's between 80 and 90, so we'll call it 85. And this one's right at 100. Okay? Now, it says use the interquartile range to identify outliers. Interquartile range, remember, IQR, is equal to Q3 minus Q1. Well, this is the minimum, the maximum. We have Q1, Q2, and the median. Okay? So, oops, I put Q2 instead of Q3. Q3, this is Q2. The median and Q2 are the same. So, Q3 is 85 minus Q1, which is 60. So, the IQR, or the interquartile range, 85 minus 60 gives us 25. Okay? Now, looking at our box and whisker plot, what number looks like it doesn't belong? And it has to be either the minimum or the maximum. And whenever you're looking at this, you can tell if it looks like an outlier because of how long the whisker is. Okay, notice that the whisker on the lower end is much longer than the whisker on the upper end. Okay, so we're going to say that if there is an outlier, it's going to be 15. So let's check it out. We know that if it's on the lower, it's going to be that x is less than Q1 minus 1.5 times the IQR. So x, which is 15, if it is less than, first quartile is 60, minus 1.5 times the interquartile range is 25. Okay. So, let me get my calculator out here. I'm going to take 1.5 times 25, because I'm following order of operations. It gives me 37.5. Bring everything else down. Then I have 60 minus 37.5 gives me 22.5. So, is 15 less than 22.5? Yes, it is. That means that 15 is an outlier. Because this is true, it works. If this had been 23, 23 is not less than 22.5, so it would not be an outlier. But because it's true, it is an outlier. Alright, example 2 says make a box and whisker plot to display the data of heights of plants in centimeters in a science experiment. So, the first thing I'm going to do is I'm going to start by arranging this data from least to greatest. So I have 72, then I have 85, 85, 87, 89, 90, then we have 94, 94, then we have 98, next we have 103, then we have 114, 118, 123, 124, and 136. And whenever I do this, I always count to make sure I have the same number. So here I have 2, 4, 6, 8, 10, 12, 14, and 15. 2, 4, 6, 8, 10, 12, 14, and 15. So they're all there. Alright, so I'm going to start by making my number line, which I can see has to range from 72 to 136. So I'm going to make it from 70 to 140. Okay, and so I have 80, 90, 100, 120. I guess I could have made them a little farther apart. It's alright. 140. And I'll just continue since I made my gaps too small. Okay, you always want to make sure that your gaps are about the same distance between, because if you make them different, it's going to throw off what your whiskers and what your each quartile looks like. So you want to make sure that they're fairly close. Clearly mine are not perfect, but as close as you can make them. Alright, so I'm going to start by plotting the 2 points that I definitely know, which is 72 as my minimum. So I'm going to say 72 would fall about here. Then my maximum is 136, which is going to fall just a little over halfway, so I'm going to put it there. Okay, then I need to find my median, so I'm going to take one off the front, one off the back. I also know that there are 15 numbers, so I could count over to 8 if you realize that. But you can also go one off the front, one off the back until you get there. So 94 is my median. 2, 4, 6, 8. So I have 94. and it's going to be a little bit less than halfway, so about here. That's my median. Now once I've found this median, I'm going to just circle my lower. I'm going to find the median of this group. So there are 2, 4, 6, 7 numbers, so that'll be my fourth number. Take one off the front, one off the back if you need to. Gets me 87, which is going to be about here. So I'm going to plot it. Then I'm going to circle my upper numbers, okay, which should also have 7. So one off the front, one off the back, till I get to my middle number or my median. Okay, oops, I crossed that one twice. 118 is that number, so it's going to be pretty close to 120. So these are my 5 points, and then all I have to do is draw my box and whisker plot. Okay, so this is it. That's all I have to do. The only other thing that I'm going to tell you, I can't remember if there's an example like it in this or not, but if I end up with 2 numbers that are in my median for the whole thing, then I would split them with the lower and the upper. Okay, I would add them and divide by 2 to find what the median of the whole thing was, but then I would split them with each side. Alright, so this is how to do it on your calculator, and it's not imperative that you know how to do this, but it is kind of nice to see what your calculator can do. And if you do not have a calculator that is a graphing calculator, it won't do it. But if you would please remind me that this is part of today's assignment, and I will teach you how to do it at the beginning of class tomorrow. The ages of the 14 members of the senior chess club are shown. So this is the 14 members. Display the data using a box and whisker plot and identify any outliers. At this time, I would like for you to pause the video, and I want you to try and do this on your own paper, from arranging them from least to greatest, to plotting them, to finding any outliers if you think that there are any. So at this time, please pause and try it on your own. So to begin, we're going to start by arranging the numbers from least to greatest. So the smallest number that we have is going to be 60, it looks like. So I have 60. Then I have 65, 2 66s, two, nope, 67, 68, another 68, 69, 3 70s, 1, 2, 3, whoops, there we go, 71, and 88. Okay, so now I can see that I need to represent numbers from 60 to 88, so I'm going to say from 60 to 90. Oh, that was a terribly not straight line. Okay, pretend like it is. So we're going to have 60, 70, 80, 90. And since these are only 4 numbers here, I'm going to just make dashes for 65, 75, 85, and we'll put one for 95 too. Alright, so starting with the ones that are obvious to me, 60 is my minimum, so I'm going to put 60. 88 is my maximum, so it's just going to be a little bit. 6, 7, 8, we'll call it right there. Okay. Then I'm going to find my median of the whole thing, and it said that there are 14, which I forgot to count. 2, 4, 6, 8, 10, 12, 14. So 2, 4, 6, 8, 10, 12. Uh-oh, I'm missing one. 60, 2, 4, 6, 8, 10, 12, 13. Alright, so 60, let's go ahead and cross that one. 60, 65, 66, 66, 67, 68, 68, it was 73. I marked the wrong one when I marked my 370s, that's why. So 73. Well, let's just erase it and make it look right, shall we? Alright, so we have 73 and then 88. Alright. Now, see, that's why you always check. Even I make crazy mistakes like that, okay? So, always check to make sure you have all the numbers, because if you don't, it's going to throw off your answer. So, we said we had 14, so I know that 7 is half of that. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So I know that these two numbers are going to be my median. So I'll do one off the front, one off the back. For those of you who prefer to do it that way, that's perfectly fine. You can see that I still ended up with those two. So I would add and divide by 2, which is going to give me a 68.5 as my median. Okay, so it's going to be really close to that 69, just over, just a skosh. We'll put it right there. Now, this is an example where I told you, you split those two to find your upper and your lower medians. So now I have 7 in each of these, so I can mark one off the front, one off the back until I get there. Or I can know that it's the fourth number. So it's not at 65, it's over just a little bit because it's at 66. And then on the other side, 1, 2, 3, 4. Okay, so it's at 70. Alright, so now I'm going to make my box and whisker. Okay, so this is my box and whisker. It says identify any outliers. So, looking at this, where does it look like there might be an outlier? You should be able to tell by the length of the whisker. So this whisker, not terribly long. This one, on the other hand, does look terribly long. So we're going to say that 88 might be an outlier, which means I have to use the x is greater than. There we go. So I have x, if x is greater than the third quartile plus 1.5 times the IQR, then it is an outlier. So to find the IQR, we remember we have to use Q3 minus Q1. So Q3 is going to be this one, which was 70, minus Q1, which was 66. So when I subtract those, I get 4. Okay, so the IQR is 4. I'm testing 88 to see if it's an outlier. So I'm going to put 88 must be greater than the third quartile, which was 70, plus 1.5 times the IQR, which was 4. Well, following now my order of operations, 1.5 times 4 gives me 6, plus 70. 70 plus 6 is 76. And 88 is, in fact, greater than 76, so it is an outlier. This data set shows the distance in miles Vince ran on his running workouts last month. It says to identify any outliers and to use a graphing calculator to make the box and whisker plot. We will do this one in class tomorrow. So make a note. Put example 4 and then write in class next to it so that whenever I'm checking your notes in the morning, I will see that and we can practice using your calculator together. So that's all I have for you, and I will see you in class tomorrow. Have a good night.